whenever we begin derivative, we have to see which type of a function is given. Differentiation, yes, basic properties according to the condition they are applicable. In among basic properties, we have seen mainly product rule and equation rule. Then and basic differentiation formula also were there, and condition was there when constant k is in multiplication with fx. Then how we solve that? By the way, in between whenever I'm solving, if that is a question mark, you can raise it. This time we will begin with the derivatives of expanded forms. Expanded form means whenever you are having two or more terms of a function. Like I say, find dy by dx if y is equal to x cube plus e to the power x plus 4x plus 5. Suppose it is given. So this is, we see this is a algebraic function, exponential function, once again algebraic, and a constant terms. So this form is expanded form. In this case, what we have to do, finding dy by dx means to differentiate both sides with respect to x. Differentiate both sides with respect to x. Now let me tell you, when we talk about the differentiation with respect to x, so there was a special comment. I said that first principle is not used in such cases. Here we differentiate using the basic properties of differentiation. Okay. First principle will be applicable, or that will be used only when it is mentioned in the question. Otherwise, it is advised not to use that. Okay. By the way, let us come back. Here, whenever you are given an equation in terms of x and y, you can see whole equation is given in terms of x and y. In that case, we differentiate directly. That is, differentiate with respect to x. Differentiate with respect to WRT x. So we will find here dy by dx. This is equal to, now according to the property, we can separate d by dx. I will repeat my statement. I will recall, this is known as differential coefficient. So this is separated in each term by the properties. D by dx of e to the power x, d by dx of 4x, d by dx of 5. Now these are all basic functions. If I want to apply the differentiation methods, I have to look for the function. This is power rule. So x to the power m, it is given. So that is why differentiation is 3. X to the power 3 minus 1 means 2. Differentiation of e raised to the power x. Every time this does not come the same way, but e to the power x, it is a basic form. So e to the power x, it's a differentiation of the function itself. Now, important thing, here we can see one constant is given in multiplication with x. This constant will be kept aside in multiplication, like 4 into, then differentiate this x. By the way, if you can do this step only, yeah, verbally it can be done. Differentiation of x with respect to x always is 1. Still, let us write here d by dx of the constant, only constant. You can see one constant term was in multiplication with x, so we kept it aside. Huh? Now, when it is here only constant, then differentiation will be 0. Again, by properties. D by dx of x is always 1. So finally we get 3x squared plus e raised to the power x plus 4. That's all. This is one expanded form where we can take the differential coefficient directly. This much. First, your doubts and comments. Now, second, we will take functions in product form. Functions in product form means when two or more functions are given in multiplication with one another. Here, if I write one example, find the differentiation, find the differentiation, or this can also be written as differentiate. What to differentiate? Suppose I say x e to the power x plus x cube log of x to the base e plus also 5 to the power x. Now you can see here product form I have written. Okay, so here x and e raised to the power x, they are in multiplication. X cube log x, they are in multiplication. 5 raised to the power x, and also this whole is in expanded form. You can see it's written terms. So first of all, let me explain. When suppose you are given only product form, then how we do. So for that, this will be the second example we will solve. First I will write here x cube 2 raised to the power x into log. Suppose this way it is. Now what is the change? I have taken a single term, a monomial, where three functions are given in multiplication. In such a case, when our functions are given in multiplication, we use a product rule. Product rule, let me write first product rule. Product rule, it is d by dx of two functions u into v, u dash v plus uv dash. Wherever dash I have used, that is for differentiation. When it comes to 3, d by dx of uvw, that is u dash rest function as it is, then uv dash w and uvw dash. That is one by one differentiate each function. When you differentiate one function, rest function they remain as it is in original form. By the way, first question. In this condition, you can see I have not mentioned anything about the function, like it was given equal to y. This whole function was given equal to y. So this is advice to you to consider this whole as y. It becomes convenient, and we will write the direct answer as d by dx. D by dx y equal to x cubed to x log x. So this will become d by dx. Now differentiation of right hand side using product rule. I have written product rule for two functions or three functions, but this is applicable on continuously. Depends how many functions are there, same number of terms we will get. Okay, so each function will be differentiated one by one. If you can do it directly being basic function, you do that. First we will differentiate x cube, so that will be 3x square into 2x log x as it is plus. Here comes the term. Now we will differentiate 2 raised to the power x cube as it is. 2 raised to the power x, its differentiation is 2 raised to the power x into log of 2 to base e into this log x as it is. Now those functions which are supposed to remain as it is without change, they can be clubbed together in advance. That is, I could write this term as x cube log x and separately in multiplication differentiation of 2 raised to the power x. I am using formula plus last term. Let me give you that example what I was explaining recently. This time we need to differentiate like log x. So already these two are clubbed. So that was the purpose, that these two functions should be written together and log x only differentiated 1 upon x. As soon as you apply product rule, write the result in the simplest form. Last term there is a cancellation. X cancels this 3. This becomes forward 2. This way we have further results. This can be further simplified. How? This is 3x squared 2x log x, no change. This is x cubed 2 raised to the power x log of 2 log x, no change. Plus this is x squared 2 raised to the power x, still no change, remain as it is. But suppose we find two or more terms, like terms, solve them. This log 2, additionally, I will speak. Log 2 base e, this is a constant, okay. This is not a function. It is just, I am saying, as it appears here. So just for your knowledge, that log 2 base e, this does not has any input as x, that's why it is a constant. Okay, by the way, that part is later. In this question, if you have doubts, raise it now only. In second question, we need to differentiate, means d by dx of x e to the power x plus x cube log x base e plus 5 to the power x. Here you can make a separate category if you want. This is two or more forms together, that is expanded form and the product form also is there. Okay, by the way, main intention is to differentiate. Obviously, in this condition, first rule, this is overall an expanded form. So differential coefficient will be taken of each term. We can write this as d by dx of x e to the power x, d by dx of x cube log x to base e, d by dx of 5 to the power x. So what we have to do here now, this is the individual differentiation. We need to see this is product rule applicable. Yeah, we do that. Apply product rule, and for a safe side, this is advised. In the beginning, you put that in bracket. Whatever operation you are doing, put that in bracket. Like differentiation of first function x, it is 1 e to the power x as it is by product rule of 2. Next, x as it is, differentiation of e to the power x. This is the best function because it's a differentiation function itself. E to the power x. Next, differentiation of the product of these two. So for this purpose, x cube, this will be solved by power rule. 3x square log x as it is base e plus x cube as it is log x to base e differentiated 1 upon x plus differentiation of 5 to the power x. Recently we did such a function, 5 to the power x log of 5 base e. Now only term which is going to be simplified is this one, x2 3 cancelled out, making square. We can take an e to the power x common if we wish, otherwise it's not going to make any big change. Here this will be e to the power x 1 plus x plus 3x square log x base e plus x square plus 5 to the power x log of 5 to base e. This way we have to do whenever a particular term is given as the part of function being in product. Now your terms in comments. Next, quotient rule, division rule means functions where they are given in division. Once again, I will consider two examples here of the same. Example 1, when we have purely two functions, exactly two functions in division. That is, we need to differentiate x cube upon e to the power x this way. Now we have two methods. Whenever these single function, you can see single functions. Okay. This can be brought up taking its power to be negative, but let me tell you, for that one additional concept is needed, chain rule. which will be done later. That is why we will follow strictly here equation rule only. Okay, what is given? One function x given numerator, other is given denominator. First of all, let us recall what does equation rule or division rule say. It says that when two functions are given in division like u upon v, we first differentiate compulsorily numerator, denominator as it is minus, then we differentiate denominator, numerator as it is overall, square on the denominator. We begin here. Now I have already said whenever you are solving basic function differentiation, no need to explain this step by step. Like x cube, I know this is numerator. It's a differentiation also verbally can be done. So first you write here, as soon as you begin, this much is enough to write. You will write 3x square, new denominator as it is, minus. Now, differentiation of denominator, again same function, e raised to the power x. So that will be written as e raised to the power x. And now, numerator as it is into x cube divided by square on the denominator, e to the power x whole square. By the way, aside I will write, you should know e to the power x, any power n is equal to e to the power nx. Yeah. Whole to the power 2, that will be e raised to the power 2x, whole cube will be e raised to the power 3x. So this is 3x square, e to the power x minus e to the power x cube. In denominator, we get e to the power 2x. But we find that common factor e to the power x is there. So this is simplification. And x also is coming out. That can be written. Wait. Here we will write e to the power x into x square common. Inside the bracket we are left with 3 minus, here we are left with x only, divided by e to the power 2x. Now already I have explained this e to the power 2x actually is the square of ex. So that's why this ex cancels the power. We are left with e to the power x only. Finally x square 3 minus x upon e to the power x. This much. This is the use of equation rule when two functions are given. This way. Now it is not a compulsion that numerator or denominator will be a single term. Okay. And this also is not a promise that other rules will not be applicable. So let us think of that form also. Example 2. Differentiate. Very simple example we will see. Differentiate. I am making a change. X cube upon e to the power x plus log x. Now we can see denominator is a two-termed expression. Yeah, each term is a basic function. Two terms are there. So we have to be alert. So I advise you, whenever such a case appears, you write its derivatives in bracket only. Then after simplifying, you open. Check. Numerator first. So 3x square. Denominator as it is. Whole denominator as it is. Minus numerator as it is into differentiate denominator. So denominator first term is e raised to the power x, e to the power x plus log x. No base is written, so it is e actually. So its differentiation comes to be 1 by x upon square on the denominator. Now you can see it's not a big job, not a challenge. We have applied the rule over. Now main thing is simplifying. How we do? So let us begin. This 3x square multiplied inside, we get 3x square e to the power x plus 3x square log x. Next, we will multiply this x cube in the bracket. So first term, we will write minus x cube e to the power x. But we see that this x cube when it goes in the second term, it's 1 by x. So this 1 by x cancels the power 3. So this will be written directly as minus x square whole divided by e to the power x plus log x whole square. This much. Yes, it was the application of equation rule, but it was some bigger form. I hope you get it. Still, your doubts and comments. Now here this I have written parametric form of function. Actually, we have to see what is this about. So far we have seen that whenever a function is given, this is a relation between x and y. If y not given, so we are free to consider the given function as y equal to y. Simply we can begin. First example, I say take y equal to given function. In parametric function, what happens? We have a parameter. Parameter means the third variable. Listen my words, this is important. Actually, in a simple language, I will explain. Parameter means a third variable other than x and y, which relates both of them. Like, if I say x is equal to t cube and y is equal to a e raised to the power t. This a is a constant. It is just like 4, 3, 2, like that. Okay. This t is the parameter. Third variable. Check. How to identify? You see function. This x, its value is given as a function t cube. Here also we have e raised to the power t. So this is function. Its input is given as t. But this whole value is of y. This whole value is given of x. X and y can be related with the help of this relation given. But not every time that will be very easy or convenient. So that's why we should learn how to differentiate this type of function directly without relating x and y. A simple question, if I say find dy by dx if x and y are given so. Now you observe, what is the meaning of dy by dx? We require differentiation of y with respect to x, but we are given the value of y in terms of t, and x also is given t cube. It is a simple formula, simple correction, manipulation. Dy by dx, check. Dy by dx can be written as dy divided by dt. Dx divided by dt means divide the numerator and denominator by the same value dt. So this gives you a new picture. Numerator is the differentiation of y with respect to t, which is possible. Denominator is the differentiation of this relation x with respect to t, which is possible. Means you mark this as first equation, this as second equation, this as third relation. First of all, we will differentiate equation 1 with respect to t this time. Differentiation with respect to t. Here differentiation with respect to t. Let us begin. Differentiate. This was all planning. In every time parametric form, this planning is applied. Differentiate equation 1 and 2 with respect to t. Give a space. These two should not be same. Huh? Now, if I do left hand side, I can write dx upon dt direct. Differentiation with respect to t, this becomes dt. Right hand side, that becomes 3t square. And here dy by dt equal to a is a constant. So by rules, this will be kept aside. We will differentiate e raised to the power t only. So we get a e raised to the power t. What is left? substitute these values, substitute these values in equation 3. Now you check dy by dx from here is equal to value of dy by dt a e to the power t upon dx by dt 3t square. Further we can't solve. This much is the answer. This much is the answer. Finally, you may see some particular solutions also. This was a limit. I decided, I saw the question. Maybe in a question you are given, find dy by dx for, this is the extension to the question, for t equal to 1. What does it mean? Listen, this is important to know. For t equal to 1, what does it mean? Find the first dy by dx and at last, every time, at last, substitute t by 1. So here, after this stage, we will write dy by dx for t equal to 1. This is equal to a e raised to the power 1 upon 3 into 1 square. Simplifying, we get a e upon 3. Yes, this is the particular solution. Particular means when such a value is given and we need to find, we need to evaluate. This is the value of dy by dx for your doubts and comments. No. Parametric function. Now we have taken this other type of function. Here we are given value of x and y in terms of parameter t, and again we need to differentiate. By the way, let us not make it very complicated. We can see that the value of x is 2 in denominator, the same as in y. So if you apply equation rule, in that case, let me remind you, we apply equation rule when functions are given in division. In this condition also we can do, but just to save your time, I will advise you. This 2 can be cross multiplied. It can be written as 2x equal to e raised to the power 2t plus e raised to the power minus t, and y can be written as 2y e raised to the power t minus e raised to the power minus t. Now, as repeatedly I am saying, the application of chain rule, we have to see next grade. One formula you should write: differentiation of e raised to the power minus x. Every time this will be minus of e to the power minus x. Means that this function comes as it is, but in front of it we get minus sign also. Okay, so far you have seen only e to the power x. So this thing will give you the direct approach. Only this small formula gives you direct approach. How? Let's see. So far we have seen in parametric case, we have to differentiate both of these relations with respect to t. Relation 1, this is relation 2. Differentiate with respect to t. Equation 1 and 2. Let's begin. Here 2 as it is, x becomes dx by dt is equal to first function e raised to the power t, this as it is. Second function I have said this will be minus of e to the power minus t. Check. Next, from here we get twice of dy by dt. Then first function e to the power t, and again e to the power minus t solved by this formula. So we get minus of minus t plus of e to the power minus t. Interesting. When we differentiated this function, we got this as the result. Check. When we differentiated the second function, we got the first one after differentiation. means it's a special observation that these two are differentiation of each other. Okay. Now, what we have to do, we need to find dy by dx. Question was find the dy by dx. So we write dy by dx. This is equal to dy upon dt, dx upon dt. Only thing we can do is to substitute the values from here. What is the value of dy by dt? Check. E to the power t plus e to the power minus t whole divided by t upon denominator e to the power t minus e to the power minus t whole divided by 2. These two cancel out. We can finish this here only, but you can compare this value. Somewhere we have seen, go back, this is the value of 2x. Why am I saying? Because in differentiation, every time you will not get such question, find dy over dx. You may get this also, prove that. Okay. So here, if I target, if I write this question in another way, prove that dy by dx, this is equal to x upon y. So this thing we need to prove that these two are equal. So we have got dy by dx up to this step only. Okay. Now substitute its value in terms of x from equation number 1. It is 2x, and value of e to the power t minus e to the power minus t from equation 2, 2y. Cancel out x upon y. Proved. This is the simplest form. Your doubts and comments first. I have taken parametric function. You can see here x is equal to 2t upon 1 plus t square. Y is equal to 1 minus t square upon 1 plus t square. What do you mean to say? This here parametric function is given, no problem. But each value is given in the quotient form, division form. Yeah. How can I say this t is available both in numerator and denominator? So if I want to find dy by dx, in that case, I have to use a quotient rule. Focus. I need to use here quotient rule. By the way, y, x both are given. If I say prove that dy by dx, this is equal to minus x upon y. Now I'll tell you how we do such questions, prove that patterns. First of all, we will follow the custom equation. Okay, let it be 2, doesn't matter. 1. Differentiate equation 1 and 2 with respect to t. So we get from here dx upon dt. Now I will apply quotient rule. Alert. This numerator, it's a differentiation. 2t, differentiation will be 2 because t, its a differentiation is 1. Denominator in multiplication as it is, minus numerator as it is. Then differentiate this denominator. What is there? This is 1 plus t square. Focus. It is 2 terms. So differentiation of 1 is 0. T square. This will be 2t. So 0 plus 2t. I will write directly 2t. Now the thing is, if you don't understand in your notes, you should write it 0 plus 2t. And you can see here I am solving directly, direct approach. I am not going to mention any step that how I did. This is needed and to you also and advised. Denominator, it's a whole square. Now what? Open the brackets, simplify. It is 2 plus 2t square. Here we get 4t square upon 1 plus t square whole to the power 2. Simplifying 2t square minus 4t square, that means 2 minus 2t square upon 1 plus t square whole square. Let it be as it is, no change. Now differentiate this y. dy by dt, numerator first. So 0 minus 2t. So we will get minus 2t into 1 plus t square, which is denominator as it is, minus. Now comes the term of denominator. Its differentiation is 2t into numerator as it is, whole divided by square of the denominator. Yes, this is an important note. I do not expand it. Why not? Reason, it does not make a change. A plus b whole square, if you apply, terms will be expanded, but that's not give something new. So let it be in this form. Same I have done here. Check. Now we will simplify the numerator. How? Multiply minus 2t inside, minus 2t into 1, minus 2t into t square, so minus 2t cube. Keep a check. Here we get minus 2t into 1 minus 2t, minus 2t and minus t square plus 2t cube upon 1 plus t square whole square. These two terms cancel out. We are left with minus 2t and minus 2t minus 4t upon 1 plus t square whole square. These are the values of dy by dt, dx by dt. Target is to prove this relation. dy by dx is involved. So first we will evaluate dy by dx equal to, write it, dy by dt dx by dt equal to value of dy by dt minus 4t upon 1 plus t square whole square. There 2 minus 2t square upon 1 plus t square whole square. These two terms will be cancelled out. Check. Next, minus 4t upon, from these two terms 2 is common, 1 minus t square, 2 cancels 4, we have only one thing, minus 2t upon 1 minus t square. Now what happens every time, like previously we did, every time it is not very much convenient to write that in terms of x and y. You could see previous case I wrote e raised to the power t, that equation. Check. If I try, I don't have that thing. Okay. Now what is what I can do here? What is there with me left? We are told that prove this is equal to minus x upon y. Okay. So how to solve such cases? We have got the value of dy by dx 1, 2. So take this as 3. Separately obtain the value of minus x upon y. Minus x upon y. Now we will find this value in terms of t. Value of x you substitute minus 2t upon 1 plus t square. Check. Upon value of y, 1 minus t square upon 1 plus t square. So this will be cancelled out. What is left with us? Minus 2t upon 1 minus t square. Compare, are they equal? 3 and 4. Check. This value is equal to minus 2t upon 1 minus t square, the value of dy by dx. Here you can write this is dy by dx and prove. Your doubts and comments now. Here I have written differentiation of a function with respect to other function. So far we have seen we do the differentiation with respect to a variable when it was parametric form. So we did the differentiation with respect to parameter, like it was t. So we did with respect to t. Generally, we differentiate with respect to x. That's why we write d by dx. Now, what is this differentiation of a function with respect to some other function? Let's take one equation. You will get it. Differentiate x to the power 4 with respect to log x to base e. Now you see, like generally we say with respect to x. Here I am saying with respect to log x. No worries. Do one thing. Consider first function as u. Let u equal to x to the power 4 and second function as b equal to log x to base e. Now say the statement once again. Differentiate u with respect to v. Yes, that you have to say. So correct interpretation is, therefore we need du by dv. Yeah, we need to find du by dv. But you can see u is a function in terms of x, v is a function in terms of x. That means we have transformed the given equation as in parametric form. हमने इसको parametric function में बना दिया. Parameter is playing as x. Check. Now x becomes parameter here for u and v. So how can we find? Apply the same theory. Du by dv. This is du upon dx upon dv by dx. Means differentiate equation number 1, equation number 2 with respect to x. Differentiate equation 1 and 2 with respect to x. What we see, this will be known as du by dx equal to 4x cubed and dv by dx equal to, it's a simple function, log x. So we get 1 upon x. Substitute these two values in this relation. You can name it 3 or directly you put du by dx. Be careful. Sometimes this happens that we interchange the values by mistake. Du by dx we take from here, dv by dx from here. Alert. We get here 4x cubed upon 1 upon x. Solve. X goes up. 4x to the power 4. Answer. That is the way. Your comments. Here we have to see next differentiation of implicit functions. Truly speaking, such function actually I have just written as a heading. Otherwise, we have done earlier. What is this about? Whenever you are given a direct relation between x and y, an equation consisting of the different terms of x and y, that is implicit function. So there already we have an equation. So we need to simply differentiate. Like for example, if y is equal x plus 2x cubed y plus x to the power 4 plus 3y square equal to 0, then find dy by dx. Now you see an equation consisting of the terms of x and y. Its basic meaning is we cannot separate them as a single term. I cannot write this relation as y equal to or x equal to. They are mixed with each other. See. So what we have to do? Two sides are there. LHS, RHS. So we need a dy by dx. Yeah, this will look bit different because dy by dx means y is available in more than one term. See? Y is here, y available in second term, third term also. So that's why we need a dy by dx, differentiation of y with respect to x. So we can get dy by dx in three places. So let's see how we do actually. Mark this as equation number 1. Given relation. Differentiate equation 1 with respect to x. First term d by dx of y square x, d by dx of twice of x cube y, d by dx of x to the power 4, d by dx of thrice of y square equal to, obviously right hand side is 0 or a constant, so differentiation will be 0. You can say d by dx of 0 this way. Proceed. Product rule, constant as a common factor, then product rule, power rule, constant aside, power rule. Now, this is a purely constant 0. Here comes the requirement of chain rule. We have to see the chain rule. So, chain rule as a partial form I will teach. Whenever you are given so far d by dx of x to the power n, everyone focus, it's very easy for you. X to the power n, you have seen this is n x to the power n minus 1. But when it comes to d by dx of y to the power n, some power of y, so this will be n y to the power n minus 1 into dy by dx. Means apply the power rule and multiply compulsorily by dy by dx. In case of y raised to the power n, let me apply first, then you can comment. Check. We need to apply power rule in this bracket. First step only we require. So here y square we will solve first. X remains as it is. So let us write x as it is into y square according to that rule. This will be 2y to the power 2 minus 1 means 1 into dy by dx. We have solved y square, its differentiation, plus y square as it is, differentiation of x, it is 1. Put bracket. Next, plus this 2 comes out. Now differentiate this whole using product rule. X cube differentiation is 3x square, y as it is. Now plus x cube as it is, y differentiation is dy by dx. Only y is always dy by dx. Plus x to the power 4, only term, chain rule, so power rule, 4x cube. Next, 3 aside, I'm writing here, plus 3, differentiation of this is y square, so apply the same rule here, y raised to the power n. So this comes 2y dy by dx and right hand side 0. Your doubts and comments in this much? After differentiating, we have observation time. Mark those terms where you find dy by dx. Our main purpose is to get dy by dx value. 1, 2, and 3. 3 terms, as I earlier said, we will get dy by dx. We need to club all these terms, but how we do that quickly, I will show. First, simplify 2xy dy by dx. This is first one. Plus y square. Multiplying 2 inside we get 6x square y. 2 multiplied in second term also. 2x cube dy by dx plus 4x cube and last item 3 to the 6y dy by dx equal to 0. To find the value of dy by dx, what we do? Check 1, 2, 3. These terms will be clubbed. See, this is step-by-step procedure. So I have already said how to save time and write the correct answer directly. Other than these dy by dx terms, first of all, shift the rest terms to the right hand side. So their sign will be changed. So right hand side means we will get first term y square, so minus all terms I see are plus, no problem. All will be negative, that means minus y square, 6x square y shifted right hand side, minus 6x square y. This term 4x cube, this is minus 4x cube. After this, what will happen? You will take dy by dx as common factor from these three terms, right? It's a coefficient you will get in bracket. That is why to get the value of dy by dx, that coefficient will be shifted here, will come in division. So why not to write that coefficient directly in division? And dy by dx you put here one time. What now this question is, what is the coefficient? Dy by dx, the first coefficient is 2xy, shortlist here. Next coefficient is 2x cube plus, right here. Next is 6y, right here. Over. This way we have got it directly. Your comments. Logarithmic differentiation means such differentiations where we manipulate the function taking log, either for the whole function or a term of it, or seems a part of it. That is fully or partial. We will use log. But all is done before differentiation. Okay. So that this differentiation can be convenient, more convenient. That is why sometimes it is an option. This is a better option. But in some cases, this is a compulsion. Let me introduce in which case this is a compulsion to use log. Whenever you are given fx, a function, powered by other function gx, means you have seen actually different types of exponential function. 3 square, here base and power both are constant. X to the power 9, base is a variable, 9 is a constant. We use power rule for such a function. This first one is a constant, so its a differentiation will be 0. You have seen that. This also we have seen using power rule. Third is 5 raised to the power x. Base is a constant, power is x. This is also exponential function. So its rule we have already seen. The differentiation of a to the power x is a to the power x log of a to base e. We have already seen log of the base we put, e to the power x is a special case. Now we are left with such a case where base and power both are variables. These examples are x to the power x, x to the power y, y to the power x, or log x raised to the power x, x to the power log x, maybe log x raised to the power log x. These are the examples where we need a log. Yes, we need to take a log. But how we use that? Let me explain. Let me see. Suppose I write here one equation. Differentiate. Simple example. differentiate x to the power x. For example, I have to do. Now, if I do, I find here, first step, I have to consider this as y. Reason? Because when we use log, listen my words, when we use log, we need an equation. Yeah. And yeah, which log I am saying? Base will be taken e every time. It's calculus, not 10. We will take the base e every time. Okay. So we say let y is equal to x raised to the power x. I have already mentioned here, in such cases, it is compulsory to use log base e. Okay, such a function should not be written, but just for information I have written. And let me tell you, more methods are there, but this is the best one. That's why I'm saying y equal to x to the power x. Use log. Differentiating x to the power x means differentiate y. Obviously, they are equal. So when I use a log, both sides to base e, no need to mention base e. Take log y, this is equal to log of x to the power x. Now we have seen the rules. If you take the log of some base x, its power comes forward in multiplication. So we get log of y equal to x into log x. This much your doubts. Now, as soon as you simplify the terms taking log, applying log, here we will start differentiation, but there is a challenge. So far we have differentiated log y, log x, not log y. Check. We have never done log y. Y alone we have done. Y to the power n also I gave a rule. But log y is our first time visual we have seen. How to make it? Write this separately. D by dx of log y. First of all, we will operate it just like log x. What happens? Log x differentiation is 1 upon x. So for log y, we write 1 upon y first into again dy by dx. Means whatever basic operation is there, the identity is there, you apply and multiply by dy by dx. This much we have to do. Okay. Now differentiate both sides with respect to x. We get 1 upon y into dy by dx equal to right hand side product rule is applicable. Do not skip that. So that is why when you start differentiation of x, it is 1 log x plus x as it is into differentiation of log x. Yeah, we know it's 1 by x. How simple it is. Check. After taking log, x to x cancelled out. We get 1 upon y dy by dx. This is equal to log x plus 1. But we need the value of dy by dx. Differentiate. Why dy by dx? Because y is equal to this function. So we will write dy by dx equal to y 1 plus log x. Yeah. What is the value of y? Go back. Substitute again. X to the power x 1 plus log x. Finally, we get this answer. Yeah. This is the way to use log in functions. Your doubts and comments? When we started with logarithmic differentiation, I said sometimes it's an option, other time it's a compulsion. In this case, we are given a relation in x and y. You can see a big problem. X plus y raised to the power 20. Who knows? If no, then this is a big one. If I try to expand like a plus b whole square, log But be careful. Check. X to the power 13, y to the power 7 equal to x plus y raised to the power 20. Log cannot be separated actually in plus and minus. This is not equal to log x plus log y. Similarly, log x minus y not equal to log x minus log y. That's why I'm saying careful. So when we apply log, no doubt log will be applicable here and right hand side also. Right hand side a single term is given, it's good. But in case here, this is in product. In product, we know very well that log of x into y, this is log x plus log y by property of log. So means we can proceed with log at this stage. I will give one more example with same terms. Then I will explain how to do. Check. Equation 1, we need to prove this relation. Use a log. So obviously it becomes log of x 30 by 7 equal to log of x plus y raised to the power 20. Open the bracket. These two are bases are in product. So we write log x to the power 13 plus log y to the power 7 equal to this moment you see this is the whole base power 20 comes ahead means 20 into log x plus y. Next, here power 13 comes forward 13 log x plus 7 log y is equal to 20 log x plus y. This is the preparation for differentiation. You can see we have not still started, not yet started. What else? Now what we have to do? Here we have to begin differentiation. Log x we can do, log y recently we wrote the formula. Here log x plus y is given. Log x plus y. So for this also, let me tell you as a formula. Nothing difficult. D by dx of log x plus y is equal to log is applied over x plus y this sum. So 1 upon x plus y first into check into differentiate this bracket now. It is 1 plus dy by dx. Every time this happens, yeah. Wherever this appears, first you write a bracket in denominator 1 upon into, then differentiate in a bracket 1 plus dy by dx. Let us proceed. We write here differentiate with respect to x. First 13 into 1 by x plus 7 into 1 upon y dy by dx equal to 20 into 1 upon x plus y into 1 plus dy by dx. The only thing which is left is simplifying. In this much your doubts and comments. Yeah, again the same thing we will do. Whenever dy by dx is available in more than one term, we need to club that. How we do? Check. First term, here be alert. 13 upon x. Second term, 7 upon y dy by dx equal to 20 upon x plus y will be multiplied in both these. 20 upon x plus y plus 20 upon x plus y dy by dx. Check. These are the two terms of dy by dx. 13 upon x will be shifted right hand side, this term left hand side. So we get 7 upon y. See, I will take directly common. 7 upon y, this will turn negative 20 upon x plus y dy by dx equal to 20 upon x plus y minus 13 upon x. Check. LCM now. We need to take LCM. LCM of y and x plus y, x plus y, cross multiply. So when x plus y multiplied to 7, we get 7x plus 7y. Y multiplied to 20, we get minus 20y. Keep a check. dy by dx equal to right hand side also x plus y into x, and cross multiplying we get 20x minus 13x. Minus will change to the bracket side. 13x minus 13y. First simplify, then we see what happens in conclusion. 7x as it is, 7y minus 20y. We get minus 13y upon y, x plus y into dy by dx equal to 20x minus 13x, which is 7x minus 13y upon x plus y x. Now when we solve this, looks a complicated one. You see, actually we have to keep observing every time. These two brackets are same, both sides. Either let this dy by dx remain here and rest of the terms shift to that side. So we cancel that directly if you understand. If not, I will do systematically. Dy by dx, this is equal to 7x minus 13y as it is with x plus y. When this fraction goes in right hand side reciprocal, we get y x plus y on 7x minus 13 y. Bracket to bracket here. Cancel out. We are left with y by x. This was the demand. We have done it. At basic level, actually, this much will be enough. I was talking about a few more complicated structures. Those we can discuss later. First, we have to focus on these patterns. Your doubts and comments first.